All right, back again. So for this one, let's go ahead and start diving into circuits. Specifically, what we're going to do is we're going to talk about the difference between series circuits and parallel circuits. And with this video, probably a little shorter one, we're just going to talk about the differences between the two, and then in the subsequent videos, we'll actually start doing some problems related to that. So following along in the text, we just got done talking about Ohm's law. And now we're on page 47, series and parallel circuits. If you're following along in the PowerPoint, there's Ohm's law. Again, I said let's skip power. And then we're going to go right into this piece here, series and parallel circuits. So I think the first place to start is right here, and that's what is a circuit. So we can define a circuit as a source of electrons and a closed path allowing electrons to flow. Most of the time, when we're doing problems with circuits, we're going to be given some kind of diagram. So if we go down here, and again, this is copied right out of the text, you can see basically a diagram of a series circuit and a diagram of a parallel circuit. And before we get into the differences between them, let's talk what these symbols mean, because we see a couple of them as we go around. So let's go back up real quick. And basically, and you can ignore this. This is actually, I don't think this is out of your textbook. I think this is out of a different one. So this table per se might not make sense. The number, you won't be able to find it, but you can follow along. So remember we talked about resistance, and that's measured in ohms. And like I said, this is nice because it has the function. Again, it inhibits the flow of electrons. So a resistor, shaped like that. If we go down a little bit further, you can see the image of a battery. And they're not always like this, but this one in particular, it has even the positive and negative terminals. The next diagram here, we have a capacitor. Capacitors, we'll get into that a little bit later on, the difference between that and a battery. You'll hear those terms used interchangeably, and I think that's perfectly fine, but there's a little bit of a difference. And then further down, we have transformers, and then diodes. Transformers and diodes, we won't be doing a whole lot with that now, but that will be to come. So if you look at this diagram of these circuits, you don't see transformers, you don't see diodes, so we're not worried about that right now. But what do we see? Well, something that jumps out at me is right here, and that's a resistor, and again, that's what that's indicating. And you see these values, there's R1, R2, and R3. So it's not uncommon for a circuit to have more than one resistor in it, which when you account for each of them, so again, this is just partial resistance in different parts of the circuit, but if you account for each of them, then you'll get the total resistance for the circuit. So when I mentioned a little bit ago that we'll be doing problems related to this, that's where we're going to be going. But for this video, we're just trying to differentiate the difference. Okay, that was a little redundant, but you get the idea. So we're trying to differentiate between a series circuit and a parallel circuit. But again, before we go back down, let's just see if is there anything else that we can identify in our diagram based on this table right here. So like I said, we're not going to have diodes. I don't see any of those. We're not going to have transformers. We're not going to have capacitors, but we do have a battery. And if you notice, it's not super clear because, like I mentioned here, it has the terminals, but our battery is right here. So what our battery is basically our source of electrons. If we had a transformer in the diagram, it could also be right here because, again, that's our source. Let's talk a little bit more about the difference between the two. So with a series circuit, as you can tell, this is basically one continuous wire. So a series circuit allows current to flow only in one path. Now, let's try to think of an example, and there's a classic example of a series circuit. So a classic example of a series circuit is our Christmas lights. Our Christmas lights have, technically you can consider each light a resistor because it has to go through it, and it's all on one path. And for some reason, if, here's the big downfall with series circuits, if there's a break, or in the example of the Christmas lights, one of the bulbs goes out, then all the other ones along that line also go out. Usually the ones before it could stay on. Of course, I think modern day Christmas lights are a little bit different where the whole thing goes out. So that's a big downfall. We can consider that a single point of failure. But how do we overcome that? Well, that's where they came up with parallel circuit. So a parallel circuit gives multiple paths for current to flow. So again, could go down this direction, could go down this direction, could go down this direction, and ultimately it's all going back that way. So most circuits, including our Xray circuit, will be a parallel circuit, but this is just a good little difference between series and parallel. This is more informational. I don't have any critical thinking problems to go along with this example, but just stay tuned because, like I said, in subsequent videos, in subsequent videos, I'll have some problems for you to work on. So again, we're building at this point, still putting the pieces together. So with that being said, stay tuned.